Yes, good morning, class. This is the second part of section 8.12. And this section, we're going to focus on examples. In the first section, if you remember, we talked about the p-value and then the critical value approaches or methods for hypothesis testing. And so here are some examples that I'm going to go over. I'm going to look at each type, whether it's a left tail, right tail, or the true tail. Okay, so this is a homework question number 1, and I will also go over some examples in class today. All right, so here's a question. It said a poll of 2,069 randomly selected adults showed that 95% of them own cell phones. The technology displayed below results from a test of the claim that 94% of adults own cell phones. Use the normal distribution as an approximation to the binomial distribution and assume a 5% significance level to complete parts A through E. Okay, and here are the results. It means that we use the StatCrunch or Minitab or something, then this is the results display. It's in this section. All right, so here is the table, and this is a test that is indicating, okay, let me change my color to something better. All right, this is the test. The test is of this form, okay, and then this is the count. So this is my x, that's the number of successes, okay. Now notice that if you do 1966 divided by 2069, you get this as a sample proportion. So basically this is your what? P hat. Okay. And then we have this value, it's a p-value, is a test statistic and all that. So the questions following are asking us these questions. 1, it said, is this a two tail, left tail, or right tail? Why is it a two tail or left tail or two tails? So this is the test, as you know. We always write our H naught, which is the P. In this case, you said if you test 94%, so that is 0.94 versus from this, okay, versus the H1, that's your alternative hypothesis, which is the P is not equal to 0.94. And so this is what is a two tail. Okay, so the answer is that it is what? Two tail test. Okay, so that is A. B, what is a test statistic? You see that this is the Z statistic. So the test statistic, which is a Z, in this case is what? 1.96 from the table. This from StatCrunch, you see that. And then he said that what is a p-value? P-value is this, okay? The p-value is that. Now, p-value is usually calculated using the percent p-value, okay? If I should calculate is the probability that my Z, okay, because my test statistic is what? Positive, my Z score is greater than 1.96. Okay, so 1.96, and this is the probability from the table as we said is equal to 0.05. Because it's a two tail, okay, it is 2 times that. Okay, it's 2 times that. So it means that if you have 2 times, and this is 0. So they'll find that probability that should be 0.05 divided by what? Divided by 2, that is 0.0225. And if you multiply by 2, you get what? 0.05. But it's given that to us. So if you were to calculate it, this is how we get it. Okay, is that you multiply, if it's a two tail, you multiply it. If you use a table, you multiply the p-value by 2. But if you the StatCrunch, it gives you that p-value already multiplied by 2. Okay, that is that. So what is a null hypothesis? As we stated before, the null hypothesis is that your HO is that the P is equal to 0.94, and then the alternative H1 or HA is what P is not equal to 0.94. So what do you conclude? So what do you conclude? Now we compare to use the p-value, say that reject, this is a decision, say reject HO if the p-value is less than equal to what, alpha. Now, according to this question, our alpha is what, 0.05. And so, and then our p-value is also 0.05. So it means that 0.05 is equal to 0.05. And it satisfies that condition. It is equal to. So because of that, we reject. So in this case, we reject HO, or reject the null hypothesis. So that's our conclusion. Our conclusion is that we reject what? The null hypothesis. Now, is that what is your conclusion based on this? So our conclusion we have to write in the context of the problem. Since we rejected the null hypothesis, we say that there is sufficient evidence to reject, okay, or to warrant rejection of the claim that 94%, according to the question, 94% of adults own cell phones. Okay, so that was a claim. If you go back to the question, said that we should claim that, test the claim that 94% of the adults own cell phones. Okay, and that's why we have this to be a tutor. All right. So the next question is what we started in 8.1. Remember the question that said that we'll complete the, we'll set it up and then complete the solution in 8.2. So here comes that question. Even though I think we did part of it, I set it up and did some conclusions, so it's kind of a repetition, but it is good to put it here again and go through the steps for a p-value approach and then what? A critical value approach. So here's the question. It says that 1,009 consumers were asked if they were comfortable with having drones deliver their purchases, and 54%. Now, if you find 54% of 1,009, you get what, 540 of them responded with no. So use these results to test the claim that most, very important to underline that, most, see that? He said what, most consumers are uncomfortable with drone deliveries at what, 5% significance level. Okay, now the word most here, that's the clue. Tell me which kind of tail. That is why this is what, a right tail. Most means that it is what, more than or is greater than. So the alternative hypothesis will have this word symbol. Okay, so that is why it is a right tail. So now let's go through the steps for a p-value approach and then what, the critical value. But we need to what, check the requirements of that. Now remember it has what, there were 3 requirements. The first one is that the 900,000 were what, they were randomly selected. Okay, so because that's a simple random sample, that's the first check. So that is true. The second is that there's what, a fixed number of what, independent trials. There's a fixed number, that is 1,009. It has 2 categories, either they responded what, yes or no. So it has 2 outcomes, success and then what, failure. In this particular case, our success with those what, who responded what. So here your success, okay, is what, is equivalent to what, those who responded what, responded no, that they don't want, they are not comfortable with their what, drone delivering their purchases. Okay, so again, success doesn't mean that it is positive. It's what is your claim, is your focus in the question. If we were to look at this particular question, look at those who responded yes, then our success will be yes, and our failure will be what? No. So in this case, success has two outcomes: success is no, and then the failure is what? Is what? Yes. So see how that works? Okay. The third requirement is that we want what? N of P. Okay. We have at least 5 successes and then what? 5 failures. Now, what is my P? My P is what is under the null hypothesis. So in this case, what is my null hypothesis? It is what P is equal to 0.5. If you want to know that majority, that's more than 50%. Even remember the P hat was what? 0.54. So we want to know if this is actually significant, statistical. Okay, so P is equal to that versus the P, or the alternative hypothesis, which is what P is in this case is greater than 0.5. And so in this case, the P we are referring to here is this value. And so my P is what? 0.5. What's my Q is 1 minus P, which is 0.5 as well. So let's find what is N times P. That is, my N is, in this case, N is what? 1009. So 1009 times 0.5 will give me 5504.5. And also N times Q is 1009 times 0.5, which also give me 504.5. Now both of these numbers are what? Greater than what? Greater than 5. So it means this requirement is satisfied. So all the 3 requirements are satisfied. That's why we have it here. Okay, therefore we can proceed with the test. Okay. Now let's look at the p-value approach. We're going to go to the steps. Some of the steps I'm going to write them again. Step 1 says that state the null and then alternative hypothesis. So your HO is what? P is equal to 0.5. My HA or H1, that's alternative, is P is greater than 0.5. Remember, this is what? It's a right tail. It's a right tail test. And then step 2, what is my significance level? What's my significance level? In this case, it's what? Alpha, which is what? 0.05. And then step 3 is a calculate what? The test statistic. Okay, so here's my test statistic. Okay, which is the Z, is given by what? P hat minus P divided by the square root of what? P times Q over what? Over N. Now, let's calculate that. I will use the start count also to show you how to calculate that. Okay, so this is actually equal to, what's my P hat? Okay, now the P hat is, okay, the 0.54 times 109. This gives me 545, which we rounded up. Okay, rounded up. Okay, you get this. And so we're going to write this as what? 545 divided by 1009 minus P, which is the value, test value under the null hypothesis, which is 0.5. Then we divide this by the square root of, okay, the P is 0.5, Q is 1 minus 0.5, which is also 0.5, divided by 1000N and 9. Now, if you compute this and evaluate it correctly, you will have 2.55. So this is my test statistic. So my Z statistic is what? 2.55. Okay, so that is step 1. Step 3. Now, it said we should calculate the word, the p-value. Step 4. Calculate the word p-value. Now, since it's a right tail, p-value is what? It's a probability that my z, okay, my test, what do you call it? My z-score is what? Greater than the test statistic, okay? Test statistic. So in this case, this is the probability that my z is what? Greater than the test statistic, which is what? 2.54. So p-value depends, okay? P-value, okay, depends, very important to note, on what? Your test statistic. Because you want to know the probability that based on your test, it is what? Greater than that. Okay. Now, if I go to my table, if I go to my table, let me share my table with you. Okay. So let me go and share my table and find out probability. Okay. So we're going to share this again. So where's my table? Right here. Okay. So remember, we are looking for what? 2.55. So we go to 2.5 under 5. 5 is this column. 0.5, 0.05 is there, and 2.5 is here. So 2.5 under 0.05 is this value here. Okay, it is this one. It is that. Okay. Now that probability is going to 1 minus. If it is going to be greater than that, it's going to be 1 minus that. So let's go back to my PowerPoint. Okay, let's go back to the PowerPoint. Okay, so this probability that we just calculated, okay, this is equal to 1 minus the probability that my z is less than or equal to 2.55. And this is the 1 minus 0.9946. So when you subtract it, you have what? You have 0.005454. So this is a p-value. So what is our decision? Okay, the decision is that if p-value, okay, is less or equal to alpha, it's a reject HO. Now our p-value we calculate is what? 0.0054, and it is less than what is alpha? Alpha is what? 5%, 0.05. So it means that here we reject what? Reject what? HO. Okay. And so what is our conclusion? That is 6. Conclusion is that there is what? Sufficient evidence is a sufficient evidence, okay, to claim that majority of what? Consumers are uncomfortable with drone deliveries. Okay, that there is sufficient evidence to proclaim that majority of consumers are uncomfortable with drones. Okay, now I can do this using StatCrunch to give me the same conclusions, and I'm going to show you how to do that before I look at the critical value approach for this. Okay, so let's go back and I'll share my start crunch with you. Okay, this is my start crunch. Now to do this, remember you must know your what? Your X, your number of successes, your N, okay, the sample size, and then you are doing whether it's a right tail or left tail. So in the start, you go to start and then proportion what? Statistics. This is one sample and it is what? With summary data. So select that and then enter your what? Number of successes. This case what? 54% times 1009. So that is what? We got 545. The number of observations is 1009. Okay, and then what is my now hypothesis is what? P is equal to 0.5. This is a right tail, so change this to what? Greater than that. So first, by default, hypothesis test for P is already checked. Is you're not doing confidence interval. This is the same thing you repeat when you're doing confidence interval like we did before. But this is test of hypothesis and say compute. So let us look at this. Now notice that, look at the p-value. It is the same what? The same 0.0054 that we use in table for. Okay. Now this is your X number of successes. That is your what? Sample size and all that. So this gives us the same what? The same conclusion. All right. Now let us go back to look at the same problem, but we are using the critical value approach. Okay. Like we said, the steps, the 3 steps will be the same. Okay. The 4, instead of calculating p-value, we'll calculate what? Critical value. Okay. And so I'm going to repeat 1, 2, 3, and then you get 4, 5 will change, but the conclusion will be the same. Okay. So let's go to that. So critical value approach. Okay. That's a step 1. We state the null and then alternative hypothesis. That is P is equal to 0.5. The alternative is what? H1 is P is greater than what? 0.5. My alpha is 0.05. Okay. My test statistic, okay, which in this case was Z, we calculated to be what? 2.55. So I'm not going to repeat that because we just calculated that. Now 4 is where you find what? Critical value. Now it's going to be one value because it's a right tail, or if it's a left tail, it'll be one value, but it's 2 values. We call it critical values if we are doing the what? 2-tail test, which we'll consider example in a minute. All right. So what is this? What's a critical value? Now your alpha is what? Is 0. What? So you use the alpha, and this is what is happening. Okay. You have this. This is your density curve. All right. Now this part is 0.5%. What is the Z value, critical value that gives you that? Okay, this is what you are looking for, Z 0.05. So to the left is 0.195. So you go to the table and then you are reading, okay, you are reading 0.95, okay, to the left. This is what you are looking for, to the left. So let's go back to our table and do that. Okay, I'm going to share my table again with you. All right. Now I'm looking for 0.95. Now 0.95 you could see is here. It falls here. Okay, which is between 1.64 and 1.65. And then what we do is that we find the average of that. Okay, and then that's what we got 1.645. So 1.64 and 1.654 because 0.95 falls directly into the middle of those 2 values. So let's go back to our solution and complete that. So that is what's my critical value. Critical value is Z is equal to what? Z 0.05 is equal to 1.64 plus 1.65 divided by 2 will give me what? 1.645. All right. Now, what's our decision? Okay, step 5, what's our decision? Now, the decision is that this is what is happening here. This is the rejection what? Reject what? HO. If it falls on the left here, we do not reject because it's a right tail. Now, my test statistic, okay, is what? 2.55, which is what? Which falls in this region because this is what is happening. Let me draw this again. My critical value is here, 1.645. And then this is where my critical value, sorry, the test statistics, which is 2.55. So this is your critical value. This is your what? Test statistic. That's my test statistic. Now you see that it falls in this region. It's a rejection region. Okay, that's a rejection region. And so because of that, since, okay, the test statistic is greater than what? Critical value. In this case, we have 2.55 is greater than what? 1.645. Therefore, reject H what? H-O. And then your conclusion is the same as what? As before. That means we have sufficient evidence to reject the claim that sufficient evidence to support actually the claim that most consumers are uncomfortable with drone deliveries. Okay, so this is one example. It's a right tail. The second example deals with the other tails. Okay, here's a left tail, and we're going to see why it is what? A left tail. Now that is homework question number 5, similar to that. Okay, so let's read the question. It said, in a recent court case, it was found that during a period of 11 years, 880 people were selected from grand jury duty, and 37 of them were from the same ethnicity. 37 of them were of the same ethnicity. So this is your sample, and that is what the proportion that followed with what? With that sample. So that tells me that this is my p-hat. Okay, let's go back. That's my p-hat. Now, it said among the people eligible for grand jury duty, 78.7% were of this ethnicity. Use 1% significance level to test the claim that the selection process is biased against allowing this ethnicity to sit on the jury, the grand jury. I want to use both approaches. Okay. Now, one thing that I didn't show you, that is using the StatCrunch to find the critical value for the other one. So before, let me finish this. Let me show you that and go back to that. Okay, let's go back and show you that. If I want to, we find it to be what? 1.645 from the previous question, the critical value. So let's use the calculator and go to normal distribution. Okay, now the probability alpha is what? That's 5%. So we want to find 5% to the right of that. So you see that we got with the same as 1.645 to 3 decimal places. Okay, so let's continue with our solution to the question. Here is it. Okay, so I'm going to do what do you call it? Using both approaches, right? Now, what is this value here? What is the 78.1? That is your test value. That goes under what? The test value is what? 0.787. This goes under the null and then alternative hypothesis. Okay? And so I'm going to state for both cases, and my p hat, okay, my p hat is what? 0.37. 0.37. Okay, which is, if you want to know the x, you have to multiply this by 800 and what? 880, and then you will be able to find that that value. Okay. Now, so let's go and solve that. The steps are the following. What's my HO? That P is now 0.787 versus, it's a left tail, it's against it one. That means that you see that 37 of them. So that is actually less than, okay, 37 of them from that ethnicity. So it means that it's less than 50%. So it is biased against it. So that's why it's left tail. All right, so H1 is what? The probability P is less than 0.7817. And that is definitely less than that. It's less than 50%. So that's step one. Step two, what is my alpha? 0.0, in this case, 0.01 or 0.10. Let's go back and check that. Okay, it's 0.01. Okay, it's 0.01. And then step three, my test statistic. My test stat, Z is equal to the p hat minus P over the square root of what? P times Q over what? Over N. So let's get these values right. Now let us find, we know that P hat is given by what? X over what? N. Now to get the X, it is what? 0.37. If you use 0.37 as your P hat, the answer will be a little bit different. The sliding, which is within the margin of error. But I want to use the same, okay, 880 divided by what? 880. So if you calculate that, that is your X, actually, the numerator is going to be 326 over 880. So I'm going to leave it like that. I'm not going to run it. So then what is my Z? Z is what? 326 over 880 minus the P. P is what? This value right here, which is 0.787. Okay, all divided by the square root of, okay, 0.787. The Q is 1 minus 0.787 divided by 880. Now, if you evaluate this correctly, you get negative 30.18. So approximately 2 decimal places is negative 30.2. Okay, so approximately is that negative 30.2. So that is my test statistic. So what is my p-value? That is 4. P-value is, okay, because it's a left tail, right? You want to find the p-value, the probability that it is what, less than, okay, less than your, what do you call it, the test statistic, which is negative 30. Let's go back. Okay, it's go to negative 30.2. Now, if you read it from the table, okay, you will notice that I want a negative 1. Let's go share that, and then I'll be able to show you the other table. Okay. So let's go back and share this time. The negative table is here. All right. Now I'm looking for negative 30. Now you notice that even in the top, negative 3.5, it's for 0.001. Okay, so negative 30 with anything less than that is 0.0001. Okay, now this value is actually less than zero. It's very, it's approximately zero. Okay. So if I go back and share my PowerPoint, okay, this probability is actually, according to the table value is 0.00101. Now, of course, step 5 is what's your decision? The decision is that since the p-value is less than, if it is less than equal to what alpha, here in this case, my alpha is what 0.01, my p-value was 0.0001. It is less than, so we reject H what H. And also our conclusion is that we reject this what there is sufficient, okay, support or evidence, okay, to claim that the selection process is biased, okay, biased against this ethnicity. To sit on the what? On the grand jury. Grand jury. All right. So that's a p-value. Now, if I use act on that using the StatCrunch, all right, let's see the p-value that will give us, and that will arrive the same conclusion. Okay, so let's go to my StatCrunch. Okay, now to do that, you go to Stat and proportional what? Proportion statistics, one sample, and with what? Summary statistics. What's the number of successes? Remember, it is what? The 0.37 times the 880. That gives me 326. Okay, you get 325 point something, but you round it up, and this is 880. Okay, what is my null hypothesis? This is what? 787, and it is what? It's a left tail, so change it to less than, and then you compute. Okay, you see that? Look at the p-value. Look at your test statistic. Negative 30.182, run it to one decimal place, that is negative 30.2. Exactly as you use a formula to get that. Okay? All right. Now, the critical value approach, we need to calculate what we call the critical value, because it's a left tail. Now, how do you do that? I'm going to show you here so that I don't have to come back. Okay, this is calculators. You go to normal distribution. Okay, now remember, you have what? Alpha is what? 0.01, that is to the left, it's the left tail. And so you want 0.01 to the left, change this to less than equal to, so let's compute that. Okay, that value is for negative 2.33, okay, to 2 decimal places. Okay, to 2 decimal places, critical value to 2 decimal places. So that would be negative 2.33. All right, if I use the table, All right, let's see if we get the same thing. I want the left, it's a negative. Okay, my test, my alpha is what? 0.01. 0.01. Now let us look at it here. 0.01, we are looking for the closest. Okay, if you look at this value here, that is what? 0.0102. And this is what? 0.0099. In fact, that the second one is what? The closest. Okay, this is closest. So the critical value in this case was negative 2.2 under what? 2.3 under 0.3. So it is what? Negative 2.33. Just the same as we got. Okay, so now let's go back and to show you the steps for the critical value approach after calculating the critical value. So I don't have to come back to do this. Well, step one is the same. Your HO is P is equal to 0.787. Your H1 is what? P is less than 0.787. Step two, my significance level, alpha is the same, 0.01, doesn't change. Step three, we calculated a Z statistic, which is what? Negative 30.2. Okay, step four, we get what? Critical what? Critical value that I just showed you. So the critical value in this case is what? Negative 2.33. Okay, so this is what is happening. That's the one we just did. You have your density curve. You have this probability to the left is your alpha, which is 0.01 using the table. And then we find this value to be 2.33. Okay, that's my critical value. So step five, we want to find the what is your decision? Okay, what's our decision here? Now, since okay, my test statistic, if the test statistic is less than or equal to critical value, then reject HO. Now, as we see, my test statistic is what? Negative 30.2. And my critical value is negative 2.33. Okay? Then you see that this is way less than. And so in this case, we will reject HO, which is same as we got using the p-value. And then my conclusion is what? The same as what? As before in this one, in this question. Okay. All right. Now we are going to do a two-tailed test. Okay. Here's a two-tailed test, similar to homework question number what? Number 6. Okay. So let us look at this question and then analyze it carefully. Okay. It says that why is it a two-tailed in the first place? And we'll talk about that. Because if you don't know the type of tail, you get the whole setup wrong, and then your conclusion will be wrong. Okay, if a 9-year-old girl did a science fair for a science fair experiment in which she tested professional touch therapists to see if they could sense her energy field, she flipped a coin to select either her right hand or her left hand, and then she asked the therapist to identify the selected hand by placing their hand just under her hand without seeing it and without touching it. Okay, among 280 trials, okay, so trials that are independent and they are simple random, the touch therapists were correct 119 times, and then use a significance level 10% or 0.010 to test the claim. Please note that to test the claim that touch therapists use a method, okay, equivalent to random guesses. Our keyword here is what? The word equivalent, means that equal. Okay? The equivalent is what? Is what? Equal. If he said is what? The method is better. If it is better, that means it's going to be, you should be getting more than what is. So that would be greater. That would be the right term. Okay, so it satisfies the three requirements, the 280 that are three, independent trials. The outcome is either they got it right or wrong. Okay, their guesses is that they get it right or wrong, or so that is why it's a two outcomes. And also, if you do n, in this case, if you do the what do you call it, your n, you have to know your HO. Your P is, in this case, is what? 0.5. 0.5 times 280, which is what? 140. So if you do NP, is definitely greater than 5, which is you get 140. It's greater than that. And if you do NQ, which is also greater than what? 5, because you get what? 140 greater than 5. All right. And so it satisfies all the three requirements. So why is it a two-tail? Now two-tail because it says that the claim is what? Equal to. So the claim goes to what? They are now hypothesis. But the alternative will be, if it's equal to, because it said it's equal to, the alternative will be what? Not equal to. Okay, so let's set it up now. Now we're going to use what? A p-value approach. Now I want you to know, we multiply the probability, the p-value by 2 if you do a two-tail, because we're doing the, each side is what? Alpha by 2. Now, so step 1, what's my HO? Is P is equal to 0.15 versus H1, which is P not equal to 0.5. H1 in the HO. 2, what's my significance level? In this case, is giving us what? Your alpha is 0.10. Okay. And then step 3, what is my test statistic? Okay, which is a Z statistic in this case is what? The P hat minus P over the what? The square root of what? P times Q divided by what? P, or under that. Okay, so what is this? Now, remember, according to the question, my P, okay, P hat in this case is what? X over what? N. According to the question, X is the 119, and the N is what? 280. And so this is what? 119 over 280 minus P, which is this value, that's 50%, 0.5, divided by the square root of 0.5, then 1 minus 0.5 divided by 280. So if we evaluate this, we get negative 2.75 to 2 decimal places. Okay, 2.75 to 2 decimal places. And so step 4 is what? Calculate your p hat. So p-value. Now p-value in this case, because it's a two-tail, please. Because a two-tail, we multiplied it by what? The probability by 2. So that's the times the probability that my z, because this is negative, is going to be to the left, is less than what? Negative 2.75. Okay. So if you read this from the table, okay, if you read from the table, you have 0.003. If you multiply by 2, you get 0.0016. And so what is my decision? Since or because 0. The p-value is less than alpha with 0.10. This is p-value here. That is your alpha is less than or equal to that. We what? rejects H or HO. And what is our conclusion? We're going to write it here, and then we will not write it in using the critical value approach. So let's write it here. We said here there is sufficient evidence, okay, to warrant or to support rejection of the claim that the therapy used a method equivalent to random guesses. The therapist use method equivalent to random guesses. Okay. Now the question says that, is it effective? Let's go back to the question. It says that, does the result suggest that the touch therapies are effective? Okay, they are effective. So to that part, the answer is what? It's not effective. So do not appear to be effective. Okay. Now remember, our claim is this. Our claim is in the null hypothesis. So if we did not reject the null hypothesis, then it means that it is what? It is equivalent to a random guesses. Now it is not. That's why we rejected the alternative hypothesis. So we accepted the alternative hypothesis, which means that the claim which is in the null hypothesis is not effective. So that's the reason. Okay. Or you can even use the numbers and see that if you do the what do you call it, 919 divided by 280, you get a probability which is less than what, 50%. So it is not, if it's effective, we want it to be more than that. That's why it is so. All right. Then let's go to the last critical value approach. The steps, 3 steps, the first 3 steps will be the same. So step 1, HO, is what your P is equal to 0.5 versus the alternative, which is P is not equal to 0.5. Okay, step 2, my alpha is same, 0.10. 3, we calculated the Z statistic, which is negative 2.75. So step 4, I want to find a critical value. Now remember here it is values because you have, this is what is happening, is a two-tail. Okay, this side you have what? Alpha by 2. And that side you have for alpha by 2. So that when you add, this is 0.05. This side is also 0.05. So when you add the 2, you get what? 10%. And so we want to find the Z values for this. What is Z? This side will be negative. This side will be what? Positive. Now, if it is 0.05, we got it to be what? 1 point. So this side is 1.645. So I'm not going to repeat that. This is 1.645. Because if it's 0.5, then area to the left here, you add everything, the middle is 90, is 90%. The middle is 90%. If you add it to 5, you get into 5, it's the same as that. So these are my critical values. It will be a plus or minus 1.645. Okay. So then what is my decision? Okay. What's your decision? The decision is that because my test statistic, remember, is what? If the test statistic or the question is that because it's a left tail, I'm going to compare, this value is what? Negative. So I'll compare with what? That value, not a positive. Very important to know. If it were positive, we'll compare with the positive critical value. Okay. If the test statistic is less or equal to the critical value, because this is negative, that's why I'm comparing with a negative. So we have the question is that, is this true? Is what? Negative 2.75 actually less than or equal to negative 1.645? You see that I did not compare with a positive because my test statistic is what? Negative. So if the positive test statistics, you compare with the what? A positive critical value. Okay, so this is true. So this is what? Yes. And so we what? Reject HO. And then your conclusion is what? The same as what? Before. Meaning that we have enough evidence to support the warrant of what? The one to warrant rejection of the claim that the therapists use a method equivalent to random walk tests. Yeah. So let us show the critical value approach using the test StatCrunch for this. It's important to do that. So StatCrunch, I open that up now. I don't need this, guys. I'm going to repeat that. Okay, I want to find the p-value. The StatCrunch, if you always have to use the StatCrunch to calculate the critical value, either the table or the StatCrunch when you're using the critical value approach. And so here I'm going to go to proportions, one sample, and with summary. Okay, what is our number of what? Successes? It was 190, and it was 280. Okay, and then my hypothesis is the same. It was 0.5. That's what I was doing. So let's calculate that. Okay. Let me make sure I got this right. So get this and that. Go back and check something here. Edit 190. Oh, the p-value is I think I got that wrong. The p-value is what? 0.102. Because if you do the table, I believe you get 0.006 minus 0.00. Okay, let me go back and check that. Okay, we go to the table, making sure we got that right. So you go here, and we want to find the probability that is less than negative. Okay, so we do -1. We are looking for probability that is less than negative 2.75. Negative 2.75. Making sure I got that right. Negative 2.75. Is 0.003. Okay, I think I did some calculations. Let's do 119 divided by 280 minus 0.5 and divided by square root of 0.5 times 0.5 is 0.25 divided by 280. And then we got, oh, I think my calculation is Let me go back and correct that. When I calculated the Z statistic, it's supposed to be the negative 2.51. Negative 2.51. I did a mistake there. So let's correct that. Go back and show you. Yeah, I got it. So let's go back here. So this calculation here, they're supposed to be negative 2.51. Okay, so if you go here, this supposed to be negative 2.51. Okay, and so if you do the negative 2.51 the table, let's see what we got. Negative 2.51. Okay, which is correct. So you got, let's go back to, okay. So then this probability here, if you read that, that should be 0.006. Then multiply by 2, you get 0.012. Okay, but it is still, it is a 0.012 is less than that, so you get that. So conclusion is the same. Okay, so that is why the start crunch, when I did, I realized that something is not right. Okay, but notice that you get what, 0.0012, same p-value. Now, when you use a start crunch, you don't multiply it by 2. It's already what? Multiplied by 2. Okay, it's already multiplied by what? By 2. So I hope that doesn't bring much confusion. Okay, so the calculation will make an error, but the conclusion is the same, and then the p-values, the critical value will not change. It will also be the same. So we need the p-value that we got the mess up. I've corrected that. Now let us go back to the last example, which is easiest. Okay. So here it says that we want to find the X. So a study of sleepwalking or nocturnal wandering, as they call, was described in the Neurology magazine, and it included information that 29.2% of this amount, this many people, American adults, have sleepwalked. What is the actual number of adults who have sleepwalked? Okay, now remember your number of successes, okay, has to be calculating is what the probability, okay, it's your p hat times what, the n. So this is equal to 0.292 times 119,136. Okay, then when you calculate that, you get 558.6. Then you round it up to the 559, rounded up. So this is the number that we're talking about. And so we're going through 3 examples, actually 4, left tail, right tail, two tail, p-value approach, critical value approach, using the tables, using the formula, and using the start crunch for everything. And so this brings us to the end of this section. And thank you. I'll see you soon.